Okay, this is a walkthrough of sort of a mock short answer, which matches up very well to what you will be expected to do for the short answer portion of the test on Monday. So if you can do everything on this worksheet, you should be able to answer every question on Monday's test. So the first thing that you're going to be asked to do is to create a graph, an appropriate graph of data. So in this case, students were curious as to which school's wrestling matches were the most popular in the district. In a particular experiment, experimenters counted how many visitors attended matches at each school, and at the end of the season, they took an average for the number of visitors attending each match. So if we take a look here, the first thing we need to decide is whether we want to make a line graph or a bar graph. And in this case, here's our data on the right. Notice we have the school and the number of visitors. This is our independent variable. This is our dependent variable. Ms. Cuesta actually told me she teaches her class dry mix. So the dependent variable, which is also called the responding variable, always goes on the y-axis. And the independent variable, which is also called the manipulated variable, so the manipulated or the independent variable, always goes on the x-axis. So this independent variable, which is typically on the left on any chart, by the way, is going to be my x, and this is going to be my y. So I'm going to go ahead and I would label school here, and then the average number of visitors here. Now, don't forget a title. It happens to be here, but on the test it will not. So you will get points for properly having the title. You will get points for properly having the correct variable on the correct axis. Don't forget, when you're labeling the axes, if there are units, include those units. So in this case, there are no specific units like milligrams or whatever, but you would write the units straight from your table to your graph. The next thing we want to decide, again, is if it's going to be a line graph or a bar graph. So notice how our independent variable is not numerical. This is not numbers. If both of these were numbers, if this was a number, this was a number, you want a line graph. But this is not a number, so this is going to be a bar graph. So I'm actually going to switch over to my answers here so you can see what the correct bar graph looks like. Okay, so here's my answer key. Now, this is an excellent example of where you may not want to start a bar graph at 0. If you did start at 0, it's okay. But what's going to end up happening is your data is going to get really crunched together. So I went ahead and started mine at about 60, and I did 62, 64, 66, and you'll notice that by doing that, it's actually going to make it a lot easier for me to see the differences between the heights of my bars. Again, there's nothing wrong with starting at 0, but this would be a really good case where you may want to start at a higher number since all your numbers are very high. And you don't have to show this little break here, but I just went ahead and showed it. So that's what the little break would look like, showing that I'm not starting at 0, that I'm starting at another number. All right, so there's my bars already filled in, and you'll also notice that I've already drawn in error bars. Now, the error bars, we're going to walk through how to do that in a moment. So we already identified, I'm just going to scroll up on my key here. We already identified that the independent variable here was the school, and the dependent variable was the number of visitors. But then, notice our next thing. It asks you, it tells you that the standard error of the mean is 1.5. So they're giving you a piece of information. That the standard error technically can be written like that. Standard error of the mean is 1.5. They want you to add error bars showing plus or minus 2 standard errors of the mean. So we're going to take our 1.5 and we're going to double it times 2. And that gives us 3. Now to graph 2 standard errors of the mean, now that we know that that's going to be 3, we're literally going to go up 3 and down 3. And we're going to do that for every single one of our bars. Now, what does that tell us? Why do they want us to graph 2 standard errors of the mean? Because that means that we're 96% confident that the true average, if we repeated this experiment multiple times, that the real average, even though it might not be 68, it falls somewhere between these numbers, somewhere between 65 and 71. Why is that important? Well, it can give us an idea of whether or not there's a statistical difference between the data, the bars. If 2 error bars overlap, we assume there's no statistical difference. For example, notice these overlap. If I slide this error bar across, it hits this one. It also hits that one. And it also technically touches that one. So there would be no statistical difference between any of these with each other because their error bars technically overlap each other. But if I look at this school, Jerry, its error bar does not overlap with Wallace. It also does not overlap with Gamer, and it also does not overlap with Colfax. So any of those would be appropriate. Jerry and Colfax, Jerry and Wallace, or Jerry and Gamer. All of those would be correct answers for which ones show statistical differences. So that's how you do that. You can always go back to my recording on how to calculate standard deviation and standard error of the mean and what those things actually tell us if you need extra help on that. I'm not going to go through it in this particular tutorial. All right, the second thing that they asked us to do, number 2, I'll just show you my work here. They asked to calculate the standard deviation for a set of 3 numbers. You will be asked to do exactly this on the test. Remember, you will always have access to the formula sheet. So, the formula for standard deviation, it's the sum of every individual data point minus the average squared over the size of the sample minus 1, and it's the square root of all that. Again, you will have that formula available to you, but you have to know how to use it. So I've already plugged in my numbers here. I calculated my average, I added the 3 numbers and divided by 3, and I got 19. So I take each of my numbers, 15 minus 19 squared, plus 20 minus 19 squared, plus 22 minus 19 squared, over the size of my sample, meaning how many numbers did I have? I had 3 numbers, so 3 minus 1, and then the square root of the whole thing. I would, if I was you, write it exactly like this. Because otherwise what ends up happening is people forget to square root at the end, or they run into a problem. Plus, if you plug this into your calculator and you get the wrong answer, I can still give you half credit because I see your work. And so that's critical. They will tell you where to round. On the test, I will tell you. I did not tell you here. But I went ahead and rounded these to the 10th place. So when I rounded that square root of 20, I get 26 over 2, square root, that's 3.6. The standard error of the mean, the formula is provided for you. It's the standard deviation over the square root of the size of your sample. So again, our sample consisted of 3 numbers, so that's the square root of 3, and our standard deviation was 3.6. So 3.6 over the square root of 3. I put a little squiggly here because it's approximate. Don't put a squiggly on your answer. Rounded to the 10th place, that's 2.1. If on the test you get this one wrong, then technically you know your standard error of the mean is also going to be wrong since it uses the standard deviation. However, if you show me your work and you took your standard deviation and plugged it into the formula correctly, you will get full credit for the standard error of the mean even though technically your numerical answer will be wrong. All right, the next thing you have to be able to do on the test is a dimensional analysis problem. So this is a sample dimensional analysis problem. I can tell you right now it will not be this problem. So it will not be these conversion factors. So I have a different tutorial on dimensional analysis that walks you through how to do it. So I'm not going to walk through it. The answer to this one should have been 8.4, but I'll really quick run through my setup. So I was given that I had 0.0075 grams of oxygen per hour. So I went ahead and wrote that piece of information that I've been given. Grams of oxygen per 1 hour. The next thing I notice is what they're asking is how many milligrams of carbon will there be fixed or produced is what that means in a 3-hour period. So the first thing I need to do is I need to get from grams of oxygen to milligrams of carbon. So I can see some conversions here. I can get from grams of oxygen to milligrams of oxygen, and that was my first step. I set it up so that my grams would cancel. If I stop here, I would be in milligrams of oxygen per hour. Now, I'm going to convert from milligrams of oxygen to milliliters of oxygen. So that was my second step. Again, I set it up so that my milligrams of oxygen would cancel. And this one, it's written in a little confusing way, but it's basically that 0.536 milligrams of carbon equals 1 milliliter of oxygen. And so here, milliliters of oxygen will cancel. And now if I multiply all this across, 0.0075 times 1,000 times 0.698 times 0.536, I get this, 2.8 milligrams of carbon. But remember, this is still just how much I make per 1 hour, because I've never canceled my hour. It's still sitting there. Since I want to know how much it will make in 3 hours, I'm going to multiply by 3. Now you might say, well, how do I know if I multiply or divide? Hours is a denominator here. So I need it to be on the top so that it cancels with my hours on the bottom. And that's how you'll get the 8.4. And again, that's rounded, and on the test I'll tell you where to round. All right, our last one, you need to be able to do a chi-square test. So the first thing, they have lawyers in Dade County. They want to find out if there's age bias in selecting jurors. The null hypothesis, there will be no statistical difference in the number of jurors of each age group. Anything logical would be acceptable here, but you want the words no difference and some kind of explanation of what you have no difference between. So you'd get a point for that. Here they're giving you the observed. To get your expected, and I have a tutorial separate on chi-square, it needs to add to 100. So you take the 100 from your observed and divide it evenly among all your options. So you notice there's 4 options, 4 age groups. So 100 divided by 4 gives me 25. Notice how all my expected are the same in a chi-square test, in this type of chi-square test, I should say. The formula is on the formula sheet. Observed minus expected squared over expected. Technically, it's the sum of all of those. So I do each row individually. 18 minus 25 squared over 25. 20 minus 25 squared over 25, etc. And I total them up. That's where the sum comes from. This is my final chi-square answer. To get my degrees of freedom, it's the number of options in my experiment minus 1. So there were 4 options. 1, 2, 3, 4. Minus 1 is 3. And to get my critical value, let me switch over to a chart to show you. Here is our chi-square chart. Sorry. So here's our chi-square chart on the left. Here's all the formulas you'll be using. Here's standard deviation, the chi-square, and the standard error of the mean. You don't need that one. All right, you always use the 0.05 row, so you can ignore the 0.01. So we're looking at this row, and remember our degrees of freedom was 3. That makes our critical value, that's our cutoff number, 7.82. So once you have your degrees of freedom, you find the correct column, always read the 0.05 row, so 7.82. So now let's go back on our answer sheet. Here was our degrees of freedom was 3, and our critical value was 7.82. And here's our key to our last part of accepting or rejecting. If our chi-square is less than the critical value, which it is, then the chi-square test passes, meaning our null hypothesis also passes. So there was no statistical difference. We accept our null, no statistical difference. Had this number been bigger than our critical value, then our chi-square test would fail, and that would mean that our null hypothesis would also fail. And therefore, there would be a statistical difference. So don't think of it as whether there's a statistical difference or not. Think of it as if it passes, the null passes. If it fails, the null fails. And then you can read your null to see what that means. All right. If you can do everything on this sheet, you should get 100 on the short answer on Monday's test. And that is 50% of the grade. The other 50% will be 17 multiple choice questions on characteristics of living things and scientific method. I highly recommend you pay attention to the Kahoot we do and the links to the Kahoots we've done, the Quizlet set, the quiz you got back, and the practice test on Canvas that's due on Monday. You should see that as a homework. And then don't forget on Mastering Biology, there is an optional assignment on characteristics of living things. Nothing to submit, but if you go to Mastering Biology, that would be very helpful. You could review those questions. You may see some of those appear on the test. If you need help, send me an email, pass by during my office hours, and I can help you.